Got this is 8 and 7 ohms. This is 11 ohms, right? Do you see how I can just ignore the rest of the circuit? Because I've basically condensed everything that the rest of the circuit does into that voltage. The rest of the circuit provides that voltage at the boundaries of this reduced resistor, right? I expand it. Notice that I expanded this guy as well, and that's because I know that this is not exactly a parallel circuit, that it's got like a series branch on it, but we know how to do that, don't we? Do you see that we can solve this branch totally separately from this branch? Yeah. Hence the term parallel. We can solve them in parallel because they're both connected to that resistor. If that's too confusing, we can go on and pretend that this is a 15 ohm resistor, but right. So this guy has a voltmeter across it, like that, yeah? Okay, so now we're set. Now we can start doing that thing we do. Let's do that thing we do, okay? This one here, to find that current, it's easy. This is a parallel circuit. The 11 ohms is connected directly to 6.862. So this current here is going to just be 6.862 divided by 11, right? So that voltage divided by 11 is 0.6238. And I don't need to use that number anymore, so I'm not going to store it. I mean, there's nothing to go down into there, right? Okay. How do we find that voltage there? Yeah, we got to find the current, don't we, right? So the next step is we got to find this current, right? This current here is going to be 6.862, right? Divided by 8 plus 7, right? So alpha C divided by 15, right? And I'm going to store that in D. So that current here is 0.4575, okay? What if we add this and this together? What do we get? Do we get 1.08? Do we? Yeah, we should, right? If we don't, then, you know, we get a Nobel Prize because we've proven that charge is not conserved, as previously thought, right? So there's my current. That's not the answer that we want, is it? We want the voltage across there. So how do we find the voltage? V is IR, right? So we're going to IR this guy, right? Okay. So the voltage across the 8 ohms, right, is equal to IR is equal to 0.4575 times 8. So times 8, and we're done. 3.6597. Yeah. It's very slick, isn't it? It's a different part of your brain than like vector field theory is, isn't it? So some people who hated last chapter love this chapter, and then vice versa maybe, right? It's like, makes my brain hurt. In general, I like these better because I can picture a wire. Hard for me to picture a vector field. If I try, though, I think I can. Are there questions about this one? Okay, so let's dive into the last one. Okay, so this guy is Hmm? On the last part, what's the question about the last part? Do you understand how we can say it's 6.862? So now it's just a series, it's a parallel circuit. We know how to solve that, right? Yeah? I understand that this side here is an 8 and a 7. That's really a series.
So there's
two separate circuits, yeah, basically, right? Is that? Okay, V4 is here. V3 is here. A3 is here. V2 is here. This is, I believe, this one that you're looking at right here comes from a skill set. So, you know, God help us all. This is the expectation is that we'll be able to do a double popper. So on this one, when you solve it and get down there, and the first thing you're going to get is this A1, right? If you get A1 wrong, is there any prayer of a chance that you're going to have anything else right? Yeah, not really, not so much, right? Okay, so we're hoping that you've got. Do I have everything up there correctly? Okay. Yeah, I think so. I'm thinking so. Okay, so again, 5 and a 7 is a 12, right? 12 and 11 is, and that's going to be my A, right? So that's parallel, and that's going to be 1 divided by 11 plus 1 divided by 12. Storage A. So that's my 5.739. Right? And then this guy here is going to be my B. Right? So that's 2 plus 3 plus A plus, this guy's a 3 ohm. Right? So 2 plus 3 plus alpha A plus 3, storage B. 13.739, is that what we got before? Right? This is going to be my C, and then I'm done reducing the circuit. This is another parallel, right? So 1 over 11 plus 1 over B. And I'm going to store that in C. So 1 divided by, you need to do this along with me because you don't have these values in your registers. Yeah? Plus 1 divided by alpha B. I'm going to store that in C. This value here, the 6.10896. Yeah? There we go. Now what kind of circuit is this? Yeah, this is definitely a series circuit, right? We'll not be joking about this circuit. Okay? And so it's a, I'm going to solve it like a series circuit. There's a current going here, like that, right? That current is 19 volts divided by 3 plus C plus 5, right? Where C is 6.10896, right? 6.10896, right? So 19 divided by 3 plus alpha C plus 5. I'm going to store that in D. So my D now is 1.34666168411. Swear to God, there's 3 sixes and then it diverges from that. Right? Okay. And now that's not the circuit, is it? It'd be helpful to have the right one up there, wouldn't it? All right. And so there's a ammeter right here, and we've just picked off this reading here as I'll just say it's 1.347. There it is, right? Okay. And then I also can pick up V1. And by the way, V1, and this is like an innovation, on the skill sets, I